Hello, my name is Henrik Madsen, and I will talk about a project called the Cities Project, which has been financed by the Innovation Fund Denmark, and Cities stands for Center for IT Intelligent Energy Systems. It's one of the largest projects which has been running in Denmark for the past 7 years. And I'm coming from DTU, more specifically from Applied Mathematics and Scientific Computing. And here you can find a link to the Cities project, and you can also find a link to my homepage. What I'll talk about here is the importance of digitalization for the green transition. How important it is in being able to enable the future weather-driven, low-carbon or fossil-free energy system. What we saw in 2008 was that we had 24% wind power. And here we see the upper curve shows the power load for 2 or 3 weeks. And with 25% wind, and the wind production is showing below, we saw that only rarely the wind production was bigger than the load. So at that time, the need for digitalization was not that crucial. But today, in 2020, when we have past 50% fluctuating renewables in our power system, and on top of that we also have solar power, we see a crucial need for digitalization of the energy system. So a crucial need for use of AI, Internet of Things, Internet of Services, big data, statistics, cloud computing, fog computing, edge computing, in order to unlock the flexibility which are needed for balancing the energy system of today. Historically, we had a lot of fossil-based production units, and actually all the intelligence were installed on this large centrally placed power plants. So we operate the power plants so they could match the requirement for electricity load. This system is now going to be disrupted more and more, because in the future we will only have a weather-driven energy system, so we'll not have these centrally placed fossil-based power plants. They are gone. And that implies that all the intelligence has to move from this production side to the end user side. So what we have done in the Cities project is we have started solutions through digitalization and sector coupling for matching production and demand by moving the intelligence to the end user side. In many cases, when we discuss the low-carbon future and the actual situation, people are still discussing mostly about grids, supergrids, grids connecting different countries, and batteries as solutions here. They tend to overlook the huge and good possibility by enabling flexibility, and enable this flexibility by the use of data-driven methods, use of machine learning, sector coupling, IoT, big data analytics, and so on. Of course, in the future, we'll need more grids. We'll also need more batteries. But I believe that the optimal solution is somewhere here if we are aiming at an efficient integration of the low-carbon energy system. So what we have aimed at is we have focused on the use of digitalization and other data-driven methods for integrating the different energy vectors, thermal system, power system, biomass, fuel, gas, using data and models, communication and optimization for the sector coupling. And by doing that, we have demonstrated, and we'll come back to that we can enable a lot of flexibility which are needed for the efficient transition to a low-carbon future. And actually, with the tools we have developed, we can basically already now save a lot of CO2 emissions. One of the key elements of that is a proper tools for modeling. We need models on all levels and models which are able to work in real time and assimilate data in real time. So what we have focused on is, for instance, to establish a modeling framework called gray box modeling, which are simplified models optimized for sector coupling, because they are simplified models. And these models are able to assimilate real-time data and real-time values from sensor data and use that in real-time applications. Why do we need these simplified models? Yeah, one example I can tell you about is for wastewater treatment. When we looked at the smart wastewater treatment in our first project, we got a model where they proposed to use 43 coupled nonlinear differential equations. And it took something like half an hour to calculate what will happen in 5 minutes from now. So obviously, this model were not really suitable for real-time applications. So we need simplified models. And furthermore, and maybe even more importantly, today we have a lot of sensors at the wastewater treatment plant and in the sewer system. But in a model with 43 coupled nonlinear differential equations, we have a lot of parameters, and it's simply not possible to assimilate information from all these sensors into the model. But by using gray box models, we have reduced this to 5 or 6 coupled stochastic differential equations, which still describes all the dynamics and the variability, but then with way fewer parameters, and the models can also run in real time and provide forecast and be used for control. So what we have obtained in the cities project is we have carried out a lot of demonstrations where we have demonstrated the use of digitalization in forecasting, control, and so on for saving, for CO2 reductions and so on, and for cost savings. Here, this slide shows some of the results which you can find on the city's homepage, and at that homepage you can find the description in more details. What we have shown, for instance, is that by new data-driven methods for temperature optimization in district heating network, then we can save 800 million Danish kroner annually. And that corresponds, of course, to a lot of CO2 savings as well. And this is, of course, only the temperature optimization in the district heating network. We can also do a lot of optimization on the plant and in the buildings, and I'll come back to a part of it. For heat pumps, we have started how new controllers, predictive controller for the heat pumps, and we can show that we can save 10 to 30% by these new controllers based on new forecast, also basically now. And by integrating forecast in a new version of smart house controllers, we can save 5 to 15% of the CO2 emissions. And when it looks at the heat load forecast and electricity load forecast, which are important for production planning and for many controllers, then we have also shown that we can save on the forecast side between 10 to 40% in the accuracy of the power load and heat load forecast. And for the operations on the combined heat and power plants and the district heating plants, we could easily save up to 10% by new digital solutions. If we look on the wastewater treatment plant, then we have a document that we can save between 5 to 30% by digital operation of wastewater treatment plants. A wastewater treatment plant is flexible both on the plant with the oxygen which are put into the water as a part of the process, but the wastewater treatment in general is also flexible by the sewer system, where you can use the pump in a way where you hold back water and only pump the water when you have mostly green electricity. We have seen that we can save 10 to 20% for supermarket cooling by smart controllers and forecasting. And for data centers, we have shown that by producing the cooling at night and using smart controllers and forecast, we can save up to 90% of the CO2 emission related to the cooling of data centers. So this shows that there is a lot of potentials for saving CO2 reductions basically now. But in many countries, including Denmark, we are still struggling with a regulatory framework. One of the issues we have, for instance, is that the energy taxes are constant. So that means there are no incentives to behave in a smart way, and there are no incentives then to use more electricity when it's green compared to when it's dark. So it doesn't really happen. But we have a lot of digital tools on the shelves which are ready to use basically now. These tools are based on better methods for models using digital twin gray box models, better tools for forecasting, coherent forecasts on all different scales, and new controllers. And this can be found on the city's webpage in the section called Solutions. And this here is shown a link to the webpage where you can find these solutions. Thanks a lot for your attention.